This is Alfonso Berumen again with Pepperdine University Decision Sciences, and I am now in the last segment of the R-based tutorial with this UTAUT data. So we actually went through exploratory factor analysis, we looked at reliability, and this is now looking at CFA. So we went forward with that six-factor model. We're basically saying that these are our constructs, or these are the justified constructs, and corresponding measures or items. If you haven't watched part one and part two of the tutorial, this is not going to make any sense. In fact, I just kept my session in R open and running. So in other words, I haven't dropped or removed any results or saved objects. So we're going to go forward with CFA. So CFA again is we have some sort of theoretically founded constructs and model and relationships within that. So we'll actually see how to interpret the CFA. But just as a starting point, I'm highlighting at the top. I'm going to load some libraries. I'm also just going to give you an example with facility and conditions. As I mentioned, for composite reliability, we need to have that CFA runs. We'll go ahead and do that. So that SEM tools will allow us to look at that composite reliability. So we're just going to look at just for a single, single factor, single construct, and print off that composite reliability. So that's at 0.685. It is below that zero point 0.7 threshold. We'll actually see that it gets kind of adjusted when we expand to what we would really realistically use as a six-factor or sort of six construct model. So you can see I'm specifying those, or specifying those constructs, right? P, EE, SN, FC, BI, and use, and the corresponding items or questions that correspond to that. And then we're actually going to run all this, and we'll go ahead and slight mouse issue. Sorry about that. And we'll go ahead and run all this up to the plot would be fun. So let's go ahead and run all up to that plot. So I'm going to scroll up. You can see I have my composite reliability. Let's just go with that since we looked at that just now. So you have the performance expectancy. We're good there. EE looking pretty good. Subjective norm, good. So now, yeah, you see the facility conditions now actually sufficient, right? So it's actually 0.7, and it meets that, or barely meets that cutoff threshold. Behavioral intention still problematic, and then use, we're feeling pretty good about that at above 0.7. So you can see that composite reliability, and so that might have been a justification to leave in what you had hoped to leave in for facilitating conditions, and we did take a look at that question, and I did have some criticisms about that question wording. But in any case, you can see I have all this output for CFA, and we'll take a look at that standardized output for the CFI. That's the first. Yeah, there. That's the first sort of fit metric we're looking at here. Over 0.85 is acceptable, but there's arguments that that threshold should be a little bit different, and you'll actually notice that in the literature that so there are debates around what is the exact threshold. Hopefully, your answer now is that there is a suggested, but I don't know. There's sort of some wiggle room, I would say. So you can see there you have the CFI 0.9, or sorry, 0.89. Ideally, that would be greater than 0.9. It's kind of on the cusp, but again, people would argue that maybe 0.85 is acceptable. TLI should be over zero point 0.9 again on the cusp for TLI. And so the CFI is basically comparing the fit to a null model. TLI does the same thing, but penalizes for model complexity. So kind of adjusted measure. You also have the RMSC down here. It's at 0.078. Generally, less than, it's probably fair to say that, less than or equal to 0.08 would be good or acceptable. And then less than 0.06 would be good or better, right? So we're at just at less than 0.08, and the lower the value, the better for us. Just want to reiterate that. So the lower the value, the better for us. So we're just kind of, again, kind of on the cusp there. And you also see the SRMR, that's at 0.086. Less than or equal to 0.08 is good. Less than or equal to 0.10 is marginal. And it basically measures the standardized residuals between observed and then the model implied covariances. So again, lower value is better for us. When we think about the RMSC we looked at above, that actually measures the population level approximation error. So a lower value again would be better for us for that error measure. Again, there's debate around or kind of a little bit of wiggle room, I would say, around those values or those cutoffs. But the other thing we'll look at is also the chi-square. And in fact, when I look at chi-square, it's actually up at the top. That is actually significant, which we actually don't want this to be significant, right? We actually want to not reject the null. In this case, we are rejecting that null hypothesis. But that's actually expected with large samples, right? So this would actually suggest to us that we don't have a good model fit. But in fact, it's highly sensitive to larger sample sizes. So in fact, the kind of general rule is anything over 200 probably going to get significance. So nothing to worry about there, other than we know and should recognize that chi-square is going to be sensitive to larger sample sizes. All right. So last thing I would kind of take away is the model demonstrates generally an acceptable fit, and that would support that six-factor structure. But we can also look at the reliability, which I put it here, right? So that's the second block of code that I ran, and you can see here, right? So you see those guys, and so I kind of ran through this quickly before, right? I mentioned again that behavioral intention could be problematic for us, and now FC actually meets a 0.7 cutoff. The third block here, parameter estimates that we're printing off and kind of filtering down to evaluate the standardized loadings. So this last column is actually standardized loadings, and you can actually see we're looking at, you can see kind of within each construct, the high and the low loadings, right? So 0.65 is the lowest for PE, highest is 0.7. Just kind of looking at EE, SN. So FC, let's look at FC. Yeah, so FC, you can see here this last column, 0.342. That is low, right? We already know that there was a problem there, a potential problem there. We actually went back and read the question. So that could be problematic for us and could justify removing that guy, as it is, from a mathematical standpoint, somewhat problematic, as we've seen a number of times at this point. And then you look at the BI, all of those are pretty low, right? So all those are pretty low. There may be a slight problem with that construct. And again, theory can over, sort of overpower some of this on the math side. So again, not a knock on the data that's actually used for this published research, but you can kind of see that BI has also been problematic, where that's been a common theme. And use, we're looking at, yeah, so yeah, 4 is a little bit borderline, right? 4 is a little bit borderline. Kind of anything under 0.5 in terms of the standardized loading, or that last column, could be problematic for us. And so that's one thing we might kind of look at. Yeah, so what's the punchline around that is maybe we consider revising or dropping around FC1, or maybe BI2 or BI1, based on the loadings and also the reliability value that we saw. So another um, kind of important thing we could look at is we could look at the covariances between the constructs. And if we kind of look at that, let's go up. Yeah, if you look at kind of let's go look at kind of PE, and then yeah, there you go. Yeah, you can kind of see like PE and then BI covariances. That would be, a higher correlation. Same thing with you have the BI and then use 0.682. Um, moderately correlated there as well, and then EE and BI, pretty high correlation there as well. So there are some moderate correlations, but generally our discriminant is, it seems to be supported, despite these, some of these constructs being related. In fact, the hope is that when we do the actual modeling, that they do have relationships, right? That's the whole purpose of that model. So that, is all good. So just to summarize, we looked at those fit measures. We seem to be okay-ish, or I say okay. And then we also looked at chi-square, and I mentioned it's sensitive to larger sample sizes. But let's go ahead and look at one last bit, and this is, yeah, what you could do is just create a plot, um, and if you look at this, kind of shows you the loadings, right? It's kind of hard to read, but it shows you then the um, information around uh, the the constructs and the different items associated with those constructs. It's not all that helpful. I suppose. I guess if you're a more visual person, then it might be helpful. But last thing here is modification indices. So this is actually saying, okay, well, if you want to prove the fit, what do you have to change? And so when we look at modification indices, often we're looking at a cutoff of over 10, right? So we're going to go ahead and run that. And then also take a look at those guys, and let's kind of see, oops, too far. So if you look at kind of like the largest to smallest, it's basically giving you directions on what to modify. And one of the things that is most practical in looking at these modification indices is uh, kind of just looking at items that, hey, maybe they should be somewhere else. And that's actually what it's suggesting to us is that FC1 actually might be better off with EE, right? Um, and in that case, and again, I'm not trying to adjust the published model, but in that case, we actually looked at that question, and it kind of did look like that particular construct if you actually read it in the way that I interpreted it. And so the effort expectancy, if you look at that FC1 question, it did kind of fall into that. So I'm just going to, and that's actually the top modification that's suggested. So suppose that we did that and we actually associate FC1, removed it from FC, that construct, and then moved it over to EE, and you would actually go ahead and revise that, and we'll go ahead and look at the the summary there, and you can kind of see I have the fixed output and then the previous output, and you could if you looked at this sort of detail by detail, if we look at like the CFI, much better, right? TLI, much better. Same thing with RMS EA. It's going to be now closer to an ideal cutoff at 0.067, right? Lower value is better. And then the SRMR, it actually went from kind of borderline to now pretty solid if we look at our SRMR. So that's the whole basis of these modification indices. Again, you're going to have kind of a theoretical reasoning behind making these changes, but that gives us some good information there. And the modifications did what they were supposed to, right? Which would be to improve the fit. All right. So finally, there's also potential to produce R squared values or the explained variance for each indicator. So what you would basically see from this would basically tell you how much variance in each observed variable is explained by its latent construct. Um, and so this is kind of an add-on component I'm providing here. But if I look at the this last part, and we'll kind of look at the table, and then there's also there's a table here. So the functions are kind of pre-populated for you. The table, then there's also a plot here, and we're drawing a line within the plot of uh, zero 0.5, right? So zero 0.5 is where that line is drawn. So you can kind of see here that most of these for the indicators, most of these are pretty good. Aside from if you kind of look at the below that cutoff, like PE, sort of PE4. So PE4 is a little bit weaker, and then you have kind of the use 3, BI3, use 4, BI1, and BI2. There should be a pattern here, right? You're starting to pick up on, and then FC1. We've already talked about that, right? We've talked about that a number of times. So FC1 is very weak, and this would further justify removal. Again, theory might be against that, but that is kind of helpful to see in another view, right? So anything below kind of zero 0.3 or zero 0.4, in this case, I have a line at 0.5, those should be flagged for review. FC1 and BI2 are notably low, right? Notably low. So you would want to take a look at those as well. All right. So we looked at our modification indices uh, and our kind of final results. But the main takeaway is that there could be some refinement there, or things could be better, right? Things could be better. We talked about some of those as well. So things could be a little better, and it might lead to maybe some future revisions, future scale development. But again, theory might be the winner in this case. All right. So we looked at we started with kind of exploratory factor analysis, went into looking at reliability, then finally finished with the CFA and how to leverage that. So that's the end of the R-based tutorial.